Okay, Matt, can you read the question, please?
The following particles are used to describe the structure of an atom. Underline the fundamental particles in the above list. Sir, electron
Only the electron?
and yes, sir, only electron.
Okay. So, अच्छा जनाब चले.
Sir, because neutron, proton, and quark can be broken down.
Actually, by the way, quarks cannot be broken down any further, right? So quarks are also the fundamental particles, right? Okay. Now let's move on.
The following equation represents the decay of a nucleus of CO to form nucleus Q by beta minus emission. Sir, A will be 60 and B will be 28.
60 and 28, good. And X will be,
Sir,
Zero, zero.
anti-neutrino.
sorry,
Zero, right?
Anti,
Oh, no, name. Oh,
anti-neutrino.
sorry.
Yes, the name. Anti-neutrino, right? And you have to represent it that way, 0 and 0. Perfect. Okay, let's move on. Okay, Irfan.
Uh, that's neutrino. It doesn't have the bar above it, right?
Okay.
No,
Th-
no, no. In the
this should be
shouldn't it have a bar
anti-neutrino.
above it?
Yes,
Oh, beta positive decay is what gives a neutrino. Ah,
yes.
okay.
Okay. Because look, the beta particle will have its anti-neutrino with it. Okay, a particle with an anti-particle, right, together, right? And when you have the beta positive, so beta positive itself is an anti-particle, right? So there should be corresponding neutrino there. Okay, clear?
Yeah, okay.
Okay, okay. Fine. Read the question, please.
Use the quark model to show that the charge on a proton is plus E. So plus one. So proton has two up quarks and one down quark. That is plus 203, uh, 203 plus 203 minus 103,
Okay,
which is equal to 1.
so it should be U, U, and D, right?
Yeah.
So we can say that 2 over 3 plus, sorry, minus 1 over 3 minus 1 over 3. Sorry, not, yeah,
No, plus 203.
yeah. Okay, let's move on.
Uh, the charge on a neutron is 0. That is one up quark and two down quarks, right?
Good.
So
And
203 minus 103 minus 103. That's equal to 0.
perfect. Okay, let's move on.
Uh, a nucleus of SR decays by the emission of a beta negative particle. A nucleus of what's this copper decays by an emission of a beta positive particle, beta plus. In figure 7.1, state the nuclear number and the proton number for the nucleus produced in each of these decay processes.
Okay.
So the nuclear number for my
Mm-hmm.
beta negative decay, that'll be will it be 90, right?
Yeah, will be the same. Okay, it won't be changed.
But what confuses me is the if the proton number increases, then why won't the nuclear number increase?
Okay, look. So if let's say you have a strontium 90, okay, with I think 38 proton in it. Okay, 38 proton, and it is undergoing beta negative decay. Okay, undergoing the beta negative decay, right? So the concept of beta negative decay is that one neutron decay into a proton and an electron, right? Electron is beta particle, right? Okay. Now, if you imagine that out of 90 nucleons, there should be 38 proton and how many neutrons, please? 40,
Uh,
52. Yes.
yeah,
So,
yeah.
proton and neutron, right? Now, so this is the initial composition of the strontium with 38 proton and 52 neutron, right? Now, one of the neutron get converted into proton and electron, right? So 52 be left will be decreased by 1, so it will just be left as 51, okay? And there will be the increment in the proton, right? That is basically the product of the neutron decay, right? So when you add the whole thing again, you'll still get 90. Are you getting? Is that clear?
Oh, oh, okay, okay.
Okay. So basically, you cannot see the neutron difference, right? But you can see the protons because we have the proton number there, right? And we have the nucleon number. The protons are not leaving the nucleus; they're inside, right? So they will contribute the neutrons place. Okay, clear, na?
Yeah.
Okay, perfect. So nucleon number remains the same in both the cases, 90 and 64, right? What about the sorry, yes, what about the proton number?
Proton number is 39. 39
39,
and 28.
28. Okay, good. Because in the beta positive decay, one of the proton turn into a neutron. Okay, so proton will be decreased, but you can see the increase in the neutron, right? Because it is basically inside the nucleon number. Okay, fine. Let's move on.
Is this, say the name of the force responsible for beta decay? Is this strong nuclear?
No, weak nuclear.
Or
Always, a weak nuclear force causes the decay. Okay,
causes beta decay?
it's okay. So, the weak nuclear forces causes the decay. The strong nuclear force hold the hold the nucleus. Okay, together. Is that clear? A strong nuclear force is an attractive force. It holds the nucleus together. Okay. Okay. Please move on.
Take the name of the electrons produced in each of the decay processes.
Hmm.
So beta negative decay is that's
Anti-neutrino,
anti yeah, yeah, anti
neutrino, and there should be uh
neutrino.
neutrino. Good. Perfect. Okay. Now, Gulmina, your turn,
No,
please.
it isn't it beta positive.
No, come on.
Oh no, beta positive is the antimatter. Okay, okay, never mind.
Yeah.
It's it's
So,
like the anti-electron, right?
yes, beta
So that's
positive is
why this
anti-electron,
neutrino.
and with anti-electron there should be a neutrino, right? And with electron there should be anti-neutrino. Okay,
Yeah, okay, got it.
perfect. Yes, yes, Gulmina.
Uh, a neutron within a nucleus decays to produce a proton, a beta negative particle, and an electron, antineutrino. Use the quark composition of the neutron to show that the neutron has no charge.
Okay,
So one quark upwards for the quark and two downwards. So positive 2/3 plus -1/3 plus -1/3.
good. Okay, let's move on.
Complete figure 8.1 by giving appropriate values of the charge and the mass of the proton, the beta negative particle, and the antineutrino. Antineutrino के दोनों 0 होगा.
Good.
And then for the beta particle charge is going to be -1, and then the mass is going to be 0. And
How?
positive for the...
That's 1/1836 or something.
Yes.
Oh, sorry.
Okay. So, okay, let's move on.
और प्रोटॉन का पॉजिटिव होगा 1, sorry.
right?
G.
Perfect. There should be U, right? Okay, and you can place the coulomb and coulomb with it, right?
Sir,
So
beta minus is
not the coulomb, the
zero.
element.
Okay?
Beta,
Minus is zero.
No.
it is not actually zero. It has no nucleon number. That is why we put it zero, right? But that doesn't mean it hasn't any mass. Okay, we represent beta
Uh,
particle that way, right? We represent beta particle that way, but this shows that beta contain no proton and no neutron, right? But that doesn't make it massless, right? It has a mass of 1 over 1840, which means that if you combine 1840 beta particle, so that will be equivalent to 1 proton, okay? This is the meaning. Is that clear? Yes, Imad.
Yes.
Okay.
so the reason why they have no mass is because in the forces that part leptons
No, bro.
feel a gravitation force, right?
No, no, bro. You can say the forces over here. The leptons are very small. The electrons are very small, right? And that is why you cannot.
No,
Hmm.
sorry, they'll still feel a force if they have a mass, right?
Yes,
Like a gravitational force.
electron is also experiences a gravitational force. Proton and neutron, both of
So
them.
isn't beta negative just an electron?
Yes, it is.
So it'll feel. So we can just say that it feels. I'm just saying this for explanation. I'm
Mm-hmm.
not like answer
Yeah, yeah.
sake. Uh, so we can just say that electrons feel the gravitational force. That's why they have a mass, but a very small one. So they'll experience a weaker gravitational force
Basically,
compared to
okay.
protons. Yeah.
Basically, for the particle physics level, we actually ignore all the gravitational effect. Okay. So we don't consider the gravitational force for either proton or for the electron, right? So you don't need to mention anything regarding their forces, right? Clear, na?
Yeah.
And
Okay.
because it is a mass, it has a force. It experiences a force, right? Like you can't make the argument the other way around, right? Like you cannot say that since they're experiencing the force, so they have the mass, right? The the experiencing a force or the experiencing a gravitational force is because of the mass, right? So if something has a mass, then it will experience a gravitational force, right? But if something is energy and the energy is inside the gravitational field, then that energy will not experience the gravitational force, right? Is that clear? Clear?
Ah. Yeah.
So
Okay.
probably,
Yeah.
or your explanation is it should be the other way around, right? Like if something is a mass, then it should experience a gravitational force, and not if something is inside the gravitational field, so it will experience the mass irrespective it will experiences the mass irrespective of whether it was previously mass or not, right? So this is an incorrect explanation, by the way, but khair. Okay, so Asa, by the way, appropriate charges, Asa, they are basically asking for the actual charges and not the relative charges, and we wrote down the relative charges. So it should be better to write their actual charges. That should be 1.6 exponent negative 19 and negative 1.6 exponent negative 19. And right, for the mass of the proton, it is 1.66 exponent negative 27, and it is 9.31 exponent negative 31. Okay, is that clear, guys? Yes. So now, this type of question. Okay, Imad, please read this question.
A graph of nucleon number A against proton number Z is shown in figure 7.1. The graph shows a cross labeled P that represents a nucleus P. Second, go down.
Okay.
Nucleus P decays by emitting an alpha particle to form a nucleus Q. Nucleus Q then decays by emitting a beta negative particle to form a nucleus R. On figure 7.1, use a cross to represent nucleus Q and nucleus R.
Okay. Now, so they're saying nucleus Q and nucleus R. Okay, so P decay by emitting alpha particle to form nucleus. Okay, so P decays by emitting alpha particle. So alpha particle means there should be two decrease in the
Proton
four
number.
degrees in the proton, four degrees in the nucleon, two degrees decrease in the proton. Okay, so it should be 4 14. So it should be 10 and 84, 82, and 10, 82. Right, right here. Okay, so it should be P decays into Q. Okay, now they're saying Q then decay by emitting beta particle. So
The two
um,
on one.
this remains the
Hmm.
same and um,
2 on 1.
211. Why 210? No,
Sorry.
because the proton number won't increase, right? The nucleon number, sorry. Okay, fine. So one.
State the name of the groups of particles that include the beta minus particle.
Hmm.
So what is groups?
अच्छा जनाब. State the name particle that involve leptons, hadrons there.
Oh, where beta minus cannot be broken down, so I think it's
Should be
leptons.
leptons. Okay, perfect. Now, um, let's move on.
The quark composition of one nucleon in Q is changed during the emission of beta minus particle. Describe this change to the quark composition.
Yes, can you tell?
Give me 1 second.
Okay,
Third B of proton.
proton. Why? They're asking for the quark, not the proton.
So like the quarks of the protons.
Yes.
So two up and one down.
No, not that way. They're asking which quark changes when the neutron converts into a proton because beta decay is
Oh,
that way.
so down converts to up.
No, come on,
So down converts into up.
come on.
No, I
How?
mean opposite. The opposite.
Because
Up, down is for the neutron. Okay, एक minute. Wait. The beta negative. Okay, up, down for the neutron and up, down for the proton. Okay,
So down to
so
down to up.
yeah, good. So down to a perfect. Okay. And now this is an easy question. Okay, so all of the questions follow the same pattern. Okay. Look, non-fundamental particle should be alpha, neutron, proton, right? They are not fundamental, right? And they're saying do not experience an electric force when situated in the electric field. It should be neutron, right? They has the largest ratio of the charge to mass. This is alpha, right? It has the greatest mass
Sir,
and greatest
how
charge.
is the alpha not fundamental? It cannot be broken down, right?
It can be broken down. Alpha is not a fundamental particle. Look, alpha has two neutron and two proton, right?
alpha is just a helium atom. Just
Yes, but it has
it
a
it
four
has
two plus
two
charge.
protons, right?
Yes. Okay, clear.
Also, I didn't understand the largest ratio of charge to mass or whatever that is.
Like just divide the charge and the mass. Okay. Yeah.
I got this
The-
question. I thought it was beta plus.
Um. Okay. Let's do it then. For the alpha, there will be charge to mass, so charge 2, mass 4. For beta plus, the charge is 1, the mass is 1 over 180. Yes, it should be beta plus. And for the neutron, 1 over 0. sorry, no, 0 over 1, okay, that would be just 0, and 1 over 1, okay. So yes, it should be beta plus, yes, sorry, beta plus, okay. Now that's it. So I'm ending the class. As a mainly, they give you this quark related questions, right? And they sometimes give you this mega electron volt conversion. You should be able to convert this mega electron volt into joules as 1.6 exponent negative 19. And if you have the mega electron volt, then 1 MeV should be equal to 1.6 exponent negative 13, right? So like these are their conversions. Okay. Now, so okay, just try some of the questions. Like try at least 20, 30 questions. They're very easy, right? And they're like 2 to 5 mark question, and they're like they'll take you 1 to 2 minutes at most, right? So just try them all, okay? And then um from the next class on, we'll start the yearly passable, okay? Sure.
Sir, can you send the notes as well for
Yeah,
this
yeah,
chapter?
I will send. Don't worry.
Sir, thank you. Allah Hafiz.
Okay, Allah Hafiz.
Allah Hafiz.
Allah Hafiz, guys. Allah Hafiz.
Love, sir.
Allah Hafiz.